over on the Ah, good to know. I think it doesn't do this in my Zoom. I don't know if there's an option you have to switch on that like the institutional Zooms maybe have. Anyway, no one's leaving, so that's good. Thank you. And Kayla, I don't know if you want to mention briefly the timing, and then we'll do a quick round of intros for the symposium.
Sure, as in timing of the meetings.
Yeah, well, we're thinking kind of later in Feb.
Oh, right. Yeah. So we're thinking of creating or holding another symposia later this month. So actually just a few weeks time, and hopefully everyone can give a good update on what projects they're working on, what tools they're using, and we can have a really good discussion about that. So that's kind of the next symposia planned. But also I haven't met you, Fernand and Stefan. My name's Kayla. I'm working as the project coordinator. So I'm really helping with all of the support with Reclone. I'm trying to build person profiles that kind of shows what projects we're working on, and allow all the other users to see that, and hopefully facilitate a bit more discussion about how we can help each other.
Yes, and Kayla is operating part-time across 2 different projects, so she's got a lot on her plate, and her time availability for Reclone will kind of go up and down a bit, but we are grateful for all support, so really happy to have her on board. So yeah, we're as we're now being recorded, we could just do a quick, I guess, re-intro that this is the first of a now fortnightly call to catch up on Reclone activities. So I think most people on the call know me, but Jenny, University of Cambridge, and working on the open DNA collection that we hope the Reclone community will adopt and use in their activities. Aisha, we heard that you're new to Reclone, but maybe you could tell us a little bit about your background, because I think that'll be interesting for people on the call as well.
Yeah, I'll go again. I'm Aish, master's in bioengineering at Stanford, and my research interest is point of care diagnosis. So I worked with Manu Prakash and a couple others at Stanford. That's just Manu is a pretty well-known person in like the international diagnostics community, but I'm really interested in working with like functionalization assays to diagnose bacterial diseases.
Awesome. And we'll go Fernand, Lisa, Chiara, Stefan in that order.
Okay, my name is Fernand Federici. I work I'm from Argentina, but I'm working in Chile in Católica University and iBio Institute. We work on open source technology basically for education, research, and now a little bit in diagnostics. And in the Reclone, we have been basically working and collaborating with the OBL and all the collaborators on the design of the collection, the syntax and DNA assembly, basically.
Hello, I'm Lisa. I am a master's in biotechnology at the University of Cambridge, and I've just been helping Jenny with setting up a directory of everyone involved on the website since like December, I think. And yeah, that's what I've been doing. I've been trying to get responses from everyone on this form. It's not going as quick as I was hoping, but yeah, well.
Absolutely. Yeah, and Lisa, I've had a few contacts from people who are like getting in touch for different reasons, but I think we should bring into the Reclone community. So if you're okay with it, what I might start doing is just CCing you and Kayla into those email chains, and you can get straight in there with an ask while they're keen. Great, thanks. And
hi everyone.
All right, Stefan, sorry. You've switched over places on my screen. I think we might have lost Chiara for a second. Go on, Stefan, and then Chiara can bring up the rear.
Okay, so hi everyone. My name is Stefan Kadanka. I'm based in Cameroon at Mboa Lab. So we actually work a lot in collaboration with OBL because we are one of these nodes, local node in Africa. So mostly we work on developing open source protocols, tools to produce enzyme locally. So the Mboa Lab also hosts operate as a biomanufacturing unit for beneficial bio. So yes, nice to meet you all. Thanks.
Thanks, Stefan. And Chiara, last but not least. If we have Chiara. I think we might not have Chiara, or she's muted and she can't work out.
Sorry.
There we go.
Sorry for this. So yes, I'm Chiara and I'm based in Cambridge, CAB, chemical engineering, and I'm working with Jenny as a postdoc. And I've been designing with Jenny the open enzyme collections, and yes.
And Keb internet not up to much today, it looks like. But I think we got most of that before Chiara froze. All right, so we thought we'd do some quick updates from around the community on what's going on, what grants have come in, what work has started, different things that are happening. And I know, for example, Stefan, we've just got a grant in collaboration with quite a few partners to work on RT lamp production in Cameroon, which he can maybe speak to a little bit. I know Fernand's got a bunch of stuff going on. So would anyone like to kind of kickstart? I mean, maybe Fernand, you could fill us in on what's been happening with testing the X Prize enzymes and working with Peru and all of the other good stuff.
Yes, so we started a while ago using the BST large fragment and MMLV, basically from Alex Brown, that is a long-standing collaborator of the OBL. So these enzymes are not strictly speaking part of the Reclone collection, but we started from there with very good results. And on the way, we met a lot of people and friends, old friends and new friends from the Joggle, Just One Giant Lab Open COVID initiative, and also some other collaborators here locally in Latin America, specifically from Peru and Buenos Aires. And in that context, we started to share resources that we were getting from Free Genes and protocols. We built a very good collaboration with Cesar Ramirez, that is a protein engineering group in Chile. And we have been testing all these reactions with very good results. And now I know Tamara and Isaac that are in our group. They assemble the Reclone BST, MMLV, and other enzymes, purify BST, and now we are in the process of testing them to see how well they compare to the previous purifications. And also they were putting together a small protocol for protocols.io for the assembly, the DNA assembly part, to explain very well how to make. So we should compare notes with Chiara and anybody working on the assembly step.
Fantastic, thanks for the update, Fernand. Any questions for Fernand?
No, just a comment though. Thanks, Fernand. It's really cool that you are doing this the assembly part, because I'm on my side. If I can link on what also Fernand said, like because I'm going to leave fairly soon the OBL. I'm trying to wrap up information and what is needed, and what people will feel it's essential to actually use the collection and make the collection more useful. And one of the things that I'm trying to wrap up is actually how to explain how to do the assembly and all these kind of things. So it will be good to connect on that. Yes, so that's nice that there is a protocol on protocol.io. Are you doing it like as a normal Golden Gate, like how to do it with the collections, or how are you going to design that, if I can ask?
We were doing Golden Gate with the ULoop. We also try compare with the PCA vector from ULoop just to compare the production and how well they do in the context of protein expression and purification, because the ULoop has never been tested for protein production. So we are comparing that and with the OpenB vector backbone. But yeah, absolutely. We actually, it's part of the plan to contact you and hopefully through these meetings also to get to know what is the priority, to get all on the same page and work together on that, because there is so much to do that it will make sense to what we used to talk before, how to prioritize the work and what you feel is needed in terms of the timing to get the collection out there to be known in I don't know, in the form of a publication or engaging more people, etc.
Yes, absolutely. Thanks. No, yes, I was trying actually to do. Can I ask what destination vectors you're using? I was trying to do the OBL plus SPISPink, but unfortunately, having a really hard time to clone it. I mean, I did a lot of cloning, and it's like it also on the on parts of the collection, and it worked in silico, but it just doesn't happen. And I think the only SPISPink that I have, it's the one that I've ordered as a fragment from Twist separately from free genes, because the free gene never synthesized any SPISPink basically, or not in my hand. I think they synthesized it at the second troubleshoot round anyway, which I still don't have because I don't know, they still haven't shipped it to me. I asked the second time, they should ship it soon. But anyway, the point is that I don't have yet a destination vector. So what I'm using right now to actually clone the collection and so on is really a fragment with AEF as BSA sites, which is the one that I'm also using to clone SPISPink. It's the only fragment that doesn't want to go inside that backbone. So I was curious to know which kind of backbone you're using and what's your
Yeah, I know we were using PCA from ULoop, and also Isaac and Tamara were putting together the one do you remember the one we designed that is split in 2 parts or something like that? I don't remember the number. I think it's POpenB 4 or 3, 4.
Yeah. Okay. Yes. Nice. POpenB 4. Yeah. True.
But maybe the best thing to do is to share, maybe open a thread in the forum to talk about just about the assembly, because I know it's really confusing that part. So that was the idea of trying to put together protocols to say, this is how we did it with this backbone and this backbone, and this is how it works. Just so you don't have to tell someone, just do a Golden Gate with this part, because
no, exactly. No, absolutely agree. And the reason I was trying to put SPISPink, because I wanted to put a reporter in the destination vector, so would have been easier to actually screen the positive from the negative. Do you have a reporter now on yours? Just out of curiosity, like a chromoprotein.
No, I think we're using LACSIT in the
All right.
in PA, and in the other one I don't remember, but I can check all these details for you.
Yeah, no, I can also ask Isaac, because at a certain point I was in contact with Isaac, and he's like, yes, we really wanted to put these reporter genes, and I tried, but I failed. But maybe he also tried. But anyway, okay, thanks.
Great. I think that getting the assembly stuff out there will be really helpful. Nico is also working on I know there are some Golden Gate assembly protocols for Opentrons, but she's got one that's just setting up now and is checking it out. So she's going to share the code on GitLab soon, and we can pop that on the forum as well. Unfortunately, I still haven't heard anything on our Let's Get Everyone an Opentrons grant, but I will chase that up and see if it was on the reserve list for funding. So I'll see if it's completely dead in the water, or we've still got a hope when I get a chance. Cool. Thank you, Fanan. Stefan, do you want to give us an update on what's happening in Cameroon? And maybe you could focus in on the Volkswagen Foundation grant and what's happening there.
Okay, Jenny. So, hi again, everyone. Like Jenny mentioned, this year we were lucky to to have a grant from the Volkswagen Foundation to actually work on local manufacturing of some tests for the detection of SRS COVID-19, basically. So the method is based on an Archie, basically an Archie lamp protocol. So within the process, we are very happy that we'll be able to work on doing the protein expression, maybe purification of BSC-LF large fragment, also HIV reverse transcriptase. So those are the enzymes used by the protocol. But the grant is really great. Actually, it's in collaboration with two other state and also research institutions in Cameroon. We have the CRID, basically the Center for Research in Infectious Diseases, and also the CRISA, which is the Center for Research in Military Health. So it's actually a kind of combination, interaction, and collaboration between non-governmental and governmental institutions. So in practical ways, what we'll do is basically doing the manufacturing, expressing and purifying the proteins, preparing the test in the lab, and then we share it with our collaborator. We actually have the capacities, the facilities to do the trial using the test on actual COVID samples and do the validation. So that's, I think, the objective and what will be done as the core work. So we are very happy. It's true that as a member of OBL and Reclone, we were really excited to be using some of the protocol we've been using, and also primarily we've been working a lot with OBL enzymes and plasmids, so it was really great. We use open vent DNA polymerase a lot, so since we've been able to have the technology to express and use it mostly in the format of cellular reagents, yeah, so I think in a nutshell, that's the work we do for the COVID-19 mostly, and yeah, happy to share it with the Reclone network as well, sending updates and how it's going. Thanks.
Great, thanks, Stefan. And just to mention that there's the partners in that grant are also WACBIP in Ghana and the university, well, it's a research institution associated with the University of Ghana, and also I always get the acronym wrong, the Vienna Lamp people who are at IPBM is an Austrian research institute where they've been developing an open source RT lamp protocol. So their protocol basically, but with some adjustments for the enzyme production, because they have nice ACTA HPLC systems and everything where they are. We obviously do not have that in Cameroon, so we're having to make some modifications. And other partners in the grants are the Crick Institute in London and obviously Cambridge as well. And the grant is hosted by a German institute who very kindly have stepped up to jointly apply for this funding from the Volkswagen Foundation. So yeah, we're looking forward to kicking that off, and hopefully, Stefan, we can do, we didn't give people prior warning for this meeting, but we're hoping to do some sort of 5-minute flash presentations at each of the meetings, and with a few slides and some results will be great to see. Awesome.
Well, I think maybe I can add something, maybe what we can add, since we are talking about the Reclone network. For the grants, we had the opportunity to use maybe nickel purification, like commercial one, but what we did with the protocol we had, it was important for us to use protocol share under the Reclone network to try to see if we can actually purify the proteins with maybe our own autoinduction media and maybe some simple purification method. So this is also something that I'm really excited to try about. Thanks.
Yeah, I think one of the things that would be great to try also in Cameroon is the alternative purification tags as well that aren't dependent on the nickel columns. That would be really exciting. Before we go to Kara, I'll just put in go on, Fanan. Yes.
Oh, no, one question. Are you using the enzymes described in the Kellner 2020 paper, or you're using the OVL BSTs? And because I know they use HIV and BST large fragment, but it's not the same, right?
No, they used a different sequence in the end. We did send them our plasmids as well. So we'll probably try both side by side, I think, and see which one is. Well, it'd be useful to understand. The HIV is fairly similar. I mean, the BSTLF is a known thing that there are at least 3 wild type BSTLF sequences in circulation. So it'll be super helpful if we can compare those. Maybe that's something we can talk about, Stefan, and perhaps something that Maboa Lab might have capacity for is just to run some tests with the 3. Although to be honest, it would be helpful to have some like real-time monitoring, but it will be useful to know which of the 3 BSTLFs is actually the best. It's no one's really characterized them side by side. So, but I think it will be the OBL one plus the Vienna one. And I think in Vienna they had all 3 sequences, but I don't think they compared things, because the Vienna one also, they got the sequence for BST 2.0. So theirs isn't, their original one wasn't actually BSTLF, but then they realized the BSTLF that they were working with, I think, was pretty good too. And so they didn't in the end need to use BST 2.0 equivalent. So if I recall correctly.
Can I ask which kind of test are you going to build up? Like, I'm just thinking if it will be worth to try out the oh no, Alice one with the boxes, because apparently it works very well.
Mm-hmm.
Or does it make sense? So you go, yeah.
We use the VST, the OVL, the Alex's one, the one that you colon optimize and Alex clone, and an MMLV with an empty cartridge, and it's working really well, both with Quasar probes and with the waxes. So, well, the plan is to put some off-patent enzymes in waxes system, but so far the VST large fragment working really well in our hands compared to VST2, and it's good to know that it works with the waxes and the quasar. That quasar is like, for those that don't know, it's a sequence-specific probe, kind of like TACMAN-like for RT-PCR, but for LAMP, which we find is much better than using intercalating dyes.
Yeah, we could try both approaches in Cameroon. Kara, if we can get some cartridges from Ali to Cameroon, then once they've got the enzymes, loading them into the cartridges, I'm assuming Fanan, is not that complicated.
Yes, we got the waxes, paraffin and wax, like 1 kilo and 2 kilos from the US for free. So basically, you pay for shipping. So it's easy to get samples to play a little bit. Then, if you want to scale up, as you saw the numbers the other day within the viral alert project in XPRIZE, then you need a lot of a huge amount of wax and paraffin. But to play and prototype and play around is more than enough. They can send you for free 1 kilo, half a kilo. I can give you the contact details, because I passed it also to the people of the Corona Detective in the GI, in the Open COVID initiative. They are also going to try some of the waxes.
Nice. That'd be really good. Excellent. Chiara, any updates you would like to share?
All right. So can you hear me well?
Yeah.
Good. So any updates? So nothing specifically. I mean, I really, I'm wrapping up like expression of like the like a technical preparation and ammonium sulfate precipitation and resuspension just in the storage buffer of open vent fusion And clay now, unfortunately, clay now cannot be used as a technical preparation. You need really to purify it, because otherwise, apparently, other exonucleases that contaminate the protein preparation will interfere with the clay now assembly. So that's unfortunately, it's a no-go. It's not ready for now. And what I'm doing currently is really, and I think that I received like, so Sanchita from Andy's lab did a Golden Gate with silver reagents. So she produced DSA1 and T4 ligates, and she was able to do Golden Gate with silver reagents, which is pretty powerful, I would say. So I'm just trying, because I have it and we have a reporter collection, I'm just trying a couple of assembly with the reporter collection to see how good it is in terms that if that's a possibility, and if it works in our hands, I mean that we can have a tool that we can rely on. Cellular reagents, as we know, it's like the preparation is very cheap and it's fairly easy. So it could be a very good thing to have. Yes, so this is something I'm just trying out to see if it works just firsthand. Otherwise, I will leave it there for the future. But and another thing that I'm working on right now is just again because I need to wrap up a bit. I've been working on a very short Google form to send to whoever received the open enzyme collection, to actually understand where the collections end up being, like either in an academic lab or in a in a company or in a do-it-yourself lab, and trying to understand if they have been used, if they've not been used, why. So which we know already what could be the answer, but what are the tools that are missing? Are the reagents? And if there are reagents, is it difficult to get the reagents? How difficult it is to get the reagents? And or are there people that are missing? Are there people that don't know how to do Golden Gate assembly? And is it a knowledge missing? So are there training? What kind of tools we can provide? So is it the reagent side that is missing more, like in lab that want to use the collection? Is the training side or like the knowledge side that needs to be strengthened more? Um, so I'm working on something like, it's really like, I wanted to keep it like as brief as possible. So it's really like a Google form right now would take like 1.5 minutes. It's just really multiple tick boxes. And then if people want to add an additional comments, they can. And I screamed down the list. So from Free Genes, they said like there are 40 people that actually received the connection, but there are lots of people that asked for it more than one time. So actually, if you screen like that down, if you chop the duplicates, we have 89 people, singular people that actually got the collections, either the open enzymes, or the diagnostics, or the expression enzyme toolkit. And these are the people I'll try to send this form. And yes, I will share the form on chat as well, or on to try and understand if you see something that needs to add or you don't like, just let me know so we can go through it. I really want to keep it as short as possible because I know people don't have time, and I would think I will focus my attention being, please, I'm a full postdoc, I have to finish my, you received this all for free, please help back a bit. So hopefully they will answer back. I don't know, we'll see. But yeah, so this is more or less what I'm doing right now. And also another thing that I tried, and sorry, then I really stopped. We were trying to, as we were discussing even before with Stefan, because today we did an ammonium sulfate precipitation together in the online, and it's very difficult to get a centrifugation. So something that we tried was like, that was suggested by Jima Gioka, was like plating express I'd say strains that can express enzymes on autoinduction media. Of course, the strain needs to be, the expression needs to be IPTG dependent, so lactose dependent. If you do that and you leave it overnight, you can scrape off the biomass, and it's pretty good the next day. And it actually, the expression is not bad at all. So what I'm doing right now is just really try to understand what's the yield in terms of biomass and what's the yield in terms of protein. I will just try it with OpenVent just because we have already a lot of data on that. But that's also one direction we are going, we are exploring, because it's really something that when you have 50 milliliter, well, already 50 milliliter, if you don't have a big centrifuge, it might be, as Stefan knows very well, a long procedure, centrifuge it down. So it's would be really good to have a simple way to harvest biomass. Then there are other centrifugation steps that are needed downstream processing, in the downstream processing, but we can sort them out later in a minute. Anyway, yes, so this is more or less what's going on here.
Great. So eventually we can just have like gigantic Petri dishes and like a windscreen wiper. We just harvest biomass off them.
Exactly.
And then
Another thing that I'm trying out tonight, actually, I would just try to, because usually people, like, you know, when they teach you how to do plates, they always tell you how much media you have to put in. But I will try to put as little as possible to see what's the what's the difference in yield. So just to cover a film of media and see how the bacteria respond on that, just to have an idea. Let's see.
Nice. Any questions for Chiara? Cool. Alrighty. So yeah, there's a lot going on. I was going to update also that we don't have any colleagues from Ethiopia on the call today, but there's another Volkswagen Foundation grant that's just kicked off with Ethiopia, where we're working with the computer-aided biology group at the Technical University of Darmstadt, Johannes Kabish and his team. Bennett is a postdoc with the Ethiopian Biotechnology Institute that Fernand and I visited sort of pre/mid pandemic. the very early stages. We had to leave early, but we have a grant there where they're taking the open enzyme collection and expressing it on the outside of bacillus spores, and the idea is to harvest the spores and just add those straight into the reactions. And so far, successful reverse transcription, so that's a good step forward. And we're just in the process of the usually very long getting everything into the right place phase of the grant now, but I'll try and get Brooke and or one of the team from Ethiopia on a future call to discuss. I've also been in touch with people in Malawi who are starting to express enzymes, and also with I got contacted from a group we've been in touch with in Thailand yesterday. So next call, we should try and expand and target a few groups individually to get them in on the action. So we'd left some time at the end to talk about themes, but I think if we'd got a large group of people, which we figured we probably wouldn't for this first call, we thought about doing some breakout rooms. But maybe we can instead pick up on the conversation about the distributed experiments, because we had one call about that already, where we pretty much decided which platforms to use to log stuff. And since then, Izzy and Kayla and Aish have taken a little look at how to kind of run this. Unfortunately, Izzy, due to family circumstances, had to drop out for a few weeks at least. But we hope that, you know, when things get a bit easier, she's able to rejoin us. Is she doing okay, Lisa?
Yeah, I talked to her quite regularly. She seems fine. I think it's obviously a really hard time, but under the circumstances, I think she's okay.
Good, that is excellent to hear. So hopefully we'll see Izzy again in the near future. But in the meantime, Kayla and Aish have stepped up and taken the mantle on the distributed experiments. And so one of the things that we were discussing when we last caught up about this was we pretty much decided that we would put protocols on protocols.io, which makes total sense, and kind of keep discussion going on the forum. The question was how to collect the data and kind of get information from people that's like normalized in some way about whether their constructs are working or not. One of the things that Chiara and I have been looking into for beneficial bio purposes is a piece of software called Survey Stack, which is developed by Greg Orstick, who Fernand knows from GOSH, They use it to collect data from across different lab sites, mostly for food and soil science right now. But that could be, you can basically, it's like Google Docs, but it's a bit more powerful, and it's intended for kind of distributed data collection. So that's one thing we could look at, to set up some surveys for people to deposit like the yield that they got. I think largely speaking though, we need to know which data to collect. And that's a function of the enzyme that you're expressing, as we all know, like enzyme activity and that sort of thing. So yeah, again, to go back to Fernand's point about prioritizing, maybe we could make a prioritized list of enzymes. I think some of them are pretty self-evident, where Aisha and Kayla could work on getting some of those survey questions together for review, and sort of, there's sort of two parts to it. One is getting the kind of the infrastructure set up, and the other is actually like going out and organizing people. And I think the second part is probably the hardest. But just to stick on the content, like if we picked, say, 5 enzymes to focus on, I think, well, one of the questions would be, if we're going to do a reverse transcriptase and some form of BST, makes most sense probably, given the what people, and maybe open vent, because we've got quite a lot of information on that. But are there any other votes? And also, if we're going to do RT, like which one? And the assays that you'd run are quite similar, but I mean, we could try and make it generic so that you're doing the same thing with HIV, RT, and MMLV, and just have people log which one they're trying to express. But any thoughts on top priorities for kind of testing enzyme yield and other enzyme related things? Would you like some more people to have a crack at Clenal, Chiara? With just like standard purification? You're gone or muted. One of the two.
Sorry, my phone is struggling a lot these days. No, it's definitely, I mean, the plasmid works very well, and it has unfortunately just a usual boring his tag on it. So it's definitely worth, I mean, as Fernando also know, Cleno assembly is simple, moreover, like for workshops and so on. So having a Cleno in hand might be useful for workshops or assembly in general. Of course, you have for Cleno assembly, you need to have like, and do tailored assembly, you need to have be able to order primers pretty easily. So maybe in some location it won't be the first choice, but it could be good. I mean, I have the plasmid. I can share to everybody, like whoever wants to try it out. The expression is really good and it's very soluble. Moreover, in an autoinduction media, get tons of it, and really, it's really good. But it needs much purer formulation and processing, which could be also open the possibility to use some tags in the open enzyme collection, like or I don't know, yes, one of those cellulose or this kind of thing, is people want to try, but again, it needs time. Yeah, that's the thing.
Yeah, and getting people to commit time is kind of one of the things. So once we've got a prioritized list of things that we want people to do, which could be, we want Clenal, but we've already tried this and we need someone to test it with HIS and or this other list of tags. Does anyone want to try it? I mean, what approaches can we leverage to encourage people to give that a go? I mean, there are some people for whom it's just useful, but like, I mean, is there some kind of in the open source software world, I mean, this would rely on us having money, which we don't have, but they do bounties where they basically say, we want you to develop this, we have this amount of money, and then people, like, not quite volunteering, I guess, but often the bounties may be quite a lot lower than you would pay, kind of to say, you know, if there's a good reason that you need that piece of software, then people just step up and do it. I don't know if there's some kind of like not monetary bounty or some kind of like system of incentives that we could use. Maybe it's kudos in the community. AdGene get a lot of, they their scientists donating stuff to AdGene get very annoyed if they don't get their blue flame trophy when their when their AdGene plasmid has been requested a certain number of times. So scientists are easily bought is my is my feeling, and like some kind of reward-based community points or like system may help with some people getting them on board. But anyway, any thoughts people have seen working in other communities?
Hi, Jenny. So I think something that can encourage a lot other people to go for it can be if we clearly explain what they can do with the enzyme and how it can help them achieve a certain specific objective. I think it can be an interesting reward for them. So I just take the case of OpenVent, having the technology and the facility to do the expression and even the research was really an added value for us. Now we use it on a daily basis on our own. Before we used to have commercial polymerase. Now when we need to do a PCR, you know that you can produce OpenVent. So I think if we can look for such strategy to show to people how they can, what they can do with the enzyme, the plasmid, yeah, so that's my thinking.
Nice, thanks, Stefan. Any other thoughts? Well, I guess this is the wrong group to ask what would motivate you, because we're all here. So sort of self-selected.
I was talking to Isaac and Tama the other day about this, and also with Chiara through the chat about the idea of independently of if this is going to be a paper or like press release or whatever, kind of like having these 5 or 4 enzymes as a model, and then use that to set the rules or the standards that we would like people to use. And also we were discussing a lot with Chiara about the mix of the Reclone and the previous enzymes for 2 reasons. One, because we have a mix of data and enzymes from everywhere. And the other is because people are very confused to what is just the Reclone collection and what is the general. So in the imaginary is more like for most of the people I talk to, they see it as basically the OBL enzymes, and that's it. So the Reclone ones, you could have the Golden Gate part, but the others ready to express are more like the open enzymes. So maybe, I don't know what do you think about the idea of basically having all in the same pot? I don't know. Because trying to differentiate the Reclone from the other enzymes seems to be tricky, because we know the details, but it's difficult to do.
Yeah, I mean, we could definitely mix it up, and so we don't have to pick the top 4 or 5, but I agree with having a model that's a sort of a data model and a way of getting people involved. I mean, one of the things we've discussed before in terms of getting people involved in doing the collections is I've spoken to a couple of people who, well, the challenge of course is COVID and when people are not doing practical teaching in person, but I've spoken to a couple of people who like run undergraduate or master's practical courses where they want their students to have a sort of self-contained mini project that is almost like a kind of unsupervised practical. Like it can't be, it's not full research, but it's kind of, it is like a self-defined and self-contained project, which might be, you know, test this enzyme, here are 5 tags, each group has a tag kind of thing, like those sorts of projects. And that the kind of the thing that would motivate the lecturers to take that on would be having easy access to the materials and easy access to some kind of protocols and teaching bump behind it that they can then deploy quite easily with their own modifications. Everyone wants to make it their own, but that's one way of, in the longer term, getting kind of a reasonable amount of data. I guess it's sort of the iGEM model, is that people test in a distributed way different parts, and then you get feedback on how well they're working and that kind of thing. But it would take, I think, right, like in the next 6 months, it's not going to happen because everybody's not in practical classes. So that's one mechanism. And if people have others. I mean, we could, the one other thing I've had is people who run, like, again, challenging with the pandemic, but they run courses or community project groups at community labs, can do bits and pieces. This is not a way of generating data fast, but it's a way of generating the long tail of data over a long period of time. I think we probably need a more direct route for, like, we just want you to test this thing, please, now in 4 weeks. Off you go and do it.
Yeah, I agree with the concern about the time, and also with the potential for the teaching. We actually use it for during the semester to send mini labs to students' home, both the RT and the fusion one. Room temperature for 10 days with pocket PCRs, and they were working really, really well.
Nice.
And you see how much money you can save from there.
I've got mine now.
Oh, nice.
Yeah, I made it. I've turned it on. It's working. I haven't done a PCR in it yet, but I've got the stuff. So I will give it a go. I've just been trying to redesign. We do a PCR assay at BioMakeSpace, which is quite a nice, like, educational one. I've been trying to redesign it to not need a restriction digest, to do the SNP genotyping using LAMP. So that's my first little educational foray with the pocket PCR. Those who haven't seen these before, they're designed by Scoudens in Switzerland, and it's €98 for the kit to make one, and it comes mostly assembled. You just have to put this bit on and the legs and like this part here, which and then it's got a space for tubes in here in the block, 5 tubes, and a little LCD screen which shows you how the reaction is running. It's very simple to use.
Yeah, and in terms of education, also we send them a piece of the engine from SARS-CoV-2 as an in vitro transcribed RNA, and also was stable. I thought this is never going to work. RNA just in a room temperature with people that have never worked with pipettes before, and it worked really well. And you see there the potential for outreach and for community practicals, and all the idea of, like, do RT-PCR of COVID, where you can explain the genome and the what is being done in diagnostics with exactly the same primers. Because I think we were using N2 primers, and then run a gel. The gel part is the one that we have we didn't solve in time, because we were using the mini PCR gel tank that is okay for running the gel, but for the visualization, I'm not very convinced.
No, we have issues with background on the mini PCR gel tanks in both Cameroon and in Ghana. It's challenging. Yeah. I need to ship you some more amber acrylic, Stefan. I have not forgotten, but I cannot. I need to find some time to get to make space for essential work purposes and cut it to size for shipment.
Okay.
Anyway, we're 5 minutes from the end, so I think this has been useful. To recap on top priority then, so we'll put Claire now on the list. BST LF, with a massive request for someone to test all 3 head to head and finalize, like, actually see which one is kind of what properties, because I don't even know. I mean, they may have, there's so many mutations, particularly between the Ellington lab one, because it's coming, I think the one that in the open enzyme collection and the NEB patent one are quite similar, but the Ellington one is from a completely different strain of Bacillus. I mean, it's a strain, it's still Bacillus subtilis, but it's just they kind of used it, I think, because it happened to be a strain where there was a much better structure, and they were doing some structural protein engineering stuff in the paper, so they took that one rather than the one that's been used at NEB, is my reading back of the situation. But it's quite different. Like, it's got a lot of mutations, and some of those mutations are in common with BST2. So I wouldn't be surprised if the Ellington lab BSTLS has, like, more thermostability than the other 2, for example. Like, it's possible, but no one's compared them that I'm aware of. So we could put those in, and then MMLV and HIV-RT and open vent. That's 5. Open vent Clenal BSTLF 3 times MMLV HIV-RT. Is there anything else that we should put in the top 5 that people can think of?
I don't remember if we have the PFU in the Reclone collection or not, because that one is working really well. PFU, live fusion. Right?
Can you remember, Chiara, if it's in there?
I can have a look.
It was,
Well, that
unfortunately, I mean, it's in the Recon collection, in the ready-made cassettes. I think that it's definitely there. It's definitely there. I don't remember if it has been synthesized in the first tranche or in the troubleshooting phase, but it's there. And I'm also not sure if that failed also the last round. I have to check, but we definitely design it. So yeah, I have to. Yeah.
Great.
I think one thing, and the other important point that I've been talking to some people in the, for example, the Juggle Open COVID, that they are studying the protein structure and planning some mutations. And I was talking to them about the idea of if they're going to release the sequence or someone is going to synthesize them, also to provide guidelines for people to make it in a way that is compatible with the whole Reclone Golden Gate syntax. So if people make new proteins, we can make the collection grow. So like just be very, like to be very explicit that the collection can grow even more if people contribute with this distributed sharing.
Definitely. I think that's something we could put on the website / forum as well as a topic on how to design your DNA parts and where to put it. Nice. All right, we've got 2 minutes remaining. Chiara, you had a...
Yes, just confirming that fusion it has been synthesized. I don't have it physically yet because it's in the second part. It's in the troubleshooting list, but it has been synthesized and was successful, so we should have it somewhere. It's probably at 3 genes. So we have it. Yeah. And then absolutely another thing that we will need to set up is how people are going to feed back parts, because this is such an important part of what we are doing, what people will do, and we play around. I mean, how to feedback physically the parts, like I have this plasmid and which procedure, like before feeding back parts that might not work, or they're going to be, we should try to avoid a bit the mess that is on the iGEM webpage if we can. Like, you never know if stuff actually worked or not, and if parts are physically there or not in the actual collection. So since it's such a small collection and it's really like oversight, it would be good to have a system in which people can feedback. Yeah, I don't know.
Great. Well, Kayla's taking notes, so she's got that down as an action to put on, and we'll put the notes on the forum, as well as a link to the recording of the meeting. Fanan, go ahead.
One very short. Also, how to redistribute, because we, for example, now I know Cecilia had some trouble with the glycerol stock, so she asked again the collection, but at some point we were discussing that we replicated the collection in case someone wanted in Chile, but also to send to other people like Peru or Argentina, so we avoid the long shipping. And maybe we should also provide guidelines about the open MTA just to keep tractability on the who is using the collection and how to do that, especially on the open MTA side, because that will be good to engage more people into open MTA business, maybe.
Yeah.
It's
Agreed.
Yeah, absolutely. It's were like very last things, like we know that if you dry down E. coli, they actually stay alive for months. So it might be worth to keep it in mind that when you prepare a collection, you might want to dry down instead of shipping in glycerol. Glycerol might be an option in condition in which exactly you get the glycerol stuck and then they're all defrosted and maybe not viable. We never checked how the plasmids are maintained. That's the only thing. But they're also clonal strain, and yeah, and they are rec A manus. So yeah, it might be worth to consider that there is that option.
Mhm.
Yes, good point. I'm making stabs instead of glycer, because that was something that we received a comment about, that like you have to defrost the whole plate if you want a couple and then pull it back, which is not.
Yeah, the distribution, this idea is non-ideal. So we've just ticked over. I think this is very productive. We've got a lot to be working on, and I think we can make some encouraging noises on the forum to get a few people down for those tasks. So I'll just hand over to Kayla and Aish if there's anything else that you want to add.
Nothing on my end. Thanks everyone for joining.
Yeah, same here.
Yeah, and thanks to Aish for hosting on her Zoom channel. So we'll be back here in 2 weeks' time, and Kayla and Aish, we should catch up some point about kind of reaching out to these other groups to sort of individually encourage them in, because I think we'll have to do a little bit of outreach and building over the next few meetings to reach beyond the people who are already really highly engaged, like everyone on this call. And Lisa, yeah, maybe a thing to note on the actions is, in terms of motivation, how on the profiles we can kind of give people kudos if they've done certain things, like shared their plasmids or kind of tested something out. Perhaps there's some kind of badging system we could employ, so that people get at least a little kind of, well done tick mark on the site. Awesome. Thank you everybody for joining, and looking forward to some more updates in 2 weeks' time. And congratulations everyone on the great work. Really nice to hear how things are progressing. Speak to you all soon.
Bye everyone.
Bye for
Bye.
now. Bye.
Bye.